Bismillahirrahmanirrahim. Chapter 23 Algebraic Fractions. Exercise 23G. Our main objective is to how can we add or subtract the fractions, and these are the steps that we are going to follow to add or subtract the fractions. So first of all, we will find the LCM of the denominators. Then we will try to make both fractions or the three fractions so that their denominators will look like the LCM by multiplying both the numerator and denominator with the same number. Okay, and then we will add or subtract only the numerators and we will keep the denominator same. Let's see some of the examples here, and I have written the steps. So by looking at these steps, we are going to solve although these examples are already solved, but I will explain you step by step. So let's say we want to add these two fractions. So first of all, what we will do, we will find the LCM of the denominators. Now what are the denominators here? It's x and x squared. So if you remember in the last video, I explained you how to find the LCM. So whenever we want to find the LCM and we have the variables, we will compare their exponents. So here the exponent of x is 1 and here the exponent of x is 2. It means the variable that is with the greatest power will become the part of the LCM. So right now the LCM is only x squared, right? This shows that this fraction has denominator or already like the LCM, right? So I have nothing to change in this fraction. I'll keep it as 2 out of x squared. What about this fraction? It does not have its denominator like the LCM. So to make this x look like x squared or to become like x squared, I will multiply the denominator by x and I will multiply the numerator by x. So this one will give us x times 1, it will give me x, and x times x will give me x squared. Is it clear that I have multiplied the numerator and the denominator both by x, so I can have in the denominator x squared like the LCM. So I got x over x squared plus 2 over x squared. Now clearly I have the same denominators. For example, if I have 1 over 4 plus 2 over 4. So how can I can add these two fractions? I will keep the denominator and then I will add the numerators. That will give me 3 out of 4. Right? So here I have the denominator x squared, I have the denominator x squared. I will keep the same denominator, and in the numerators I will add both the numerators. So what are the numerators? X plus 2. So I will write x plus 2 in the numerator. Now because both are these unlike terms, x and 2, so I will leave them like this. But in case they will be like terms, then I will simplify those terms. Clear? Now let's see the second example. Here the denominator is AB and here the denominator is ABC. So if I want to find the LCM, I have to compare each letter with the other letter. So if A, B, C, here they have the same power, so they will become part of the LCM. B and B, they have the same power because they are having power 1 and power 1. So B and B, so I will take ones in the LCM. What about C? Here the power of C is 1 and here I don't have any C. So it means I will take the C that is with the power 1. So usually when it's power 1, we do not write on it. So the LCM will become ABC. This one is already like the LCM, so nothing I have to do it over here. But when I look at the second variable, it's only AB. So AB here, C is missing. That's why I will multiply here the denominator by C and here the denominator by C. So this one will give me 2C in the numerator, and in the denominator I will have ABC. Right? AB times C, that will be ABC. And this fraction will remain as it is because I'm not multiplying it any numerator or denominator by any number, so it will be 3 out of ABC. Now I will write the denominator once because both of them, they have the same denominator, and in the numerator we add the this one and this one, we will add these. Now 2C plus 3, because they are unlike terms, so I will leave them like this. Let's say in case you will get a numerator like, let's say 2x plus x over whatever, let's say 4y. Now if you will find a case like this, because these two are like terms, they can be added together, so it will give you 3x over 4y. In both these cases, the examples that I have written over here, because these are unlike terms, 2c plus 3, it's unlike, they cannot be, these terms are unlike, they cannot be added together, so you will leave them like that. Okay, let's solve some questions from the exercise now, keeping the steps in mind. First of all, I have to find the LCM of 8 and 8a. 8 and 8a. So the LCM will be, because this one, it does not have 8 and this one has 8, so the greatest you can say factor is 8, or the greatest, I have to take the one that comes with the greatest power. So this one has 1 here and this one has 8, so 8 will be the LCM. A and A both are same, so A will be the LCM. Now clearly 8A is the LCM. This one has already 8A, so nothing to do with this fraction, but this fraction I have to multiply it by 8 to get 8A. First, I have to think only about the denominator, not about the numerator. Clear? So 8 times 1 will become 8, and in the denominator I will have 8a plus 5 over 8a. Now because 8a is the same, so I will write over here 8a, the denominator. In the numerator I can add both these numerators, so finally the answer will be 13 out of 8a. Right? Now let's find what is the LCM of 7x and 5x. So 7x and 5x. First of all, I will check the numbers. The numbers are 7 and 5. So make a list of the multiples of 7, make a list of multiples of 5. So the least common multiple of 5 and 7 will be 35. Right? And when I look at x and x, both are same, so they will be placed in the LCM. So 35 is the LCM, 35x. So if you look at this one, it has 7 and x. To make it 35x, I need to multiply it by 5. So I will multiply in the denominator to make it 35x. So the same number have to be placed 5 in the numerator, right? Now here 5x, if I want to change it into 35x, so 5x times 7 can make it 35x. If I have placed this times 7 in the denominator to keep it equal, I have to place it in the numerator as well. So here it will become 20 out of 35x minus 7 2s are 14 out of 35x. Now complete the question on your own. So here is the answer for question number 17, because 35x was the denominators. You will not change it, you will keep it, and then in the numerator we will subtract 20 and 14. So finally we are getting this answer. Let's solve some more questions from this exercise. So quickly let's find what is the LCM for this one. Okay, I have 3 here and 1 here, right? So 3 and 1, their LCM is always 3. Okay, q and q squared. Which one is with the greater power? Q squared is with the greater power. So the one that comes with the greater power, it becomes part of the LCM. So this is the final LCM, 3q squared. Okay, better pause the video here and complete this question on your own, and then play the video to check your answer. So here is the answer for question number 30. Clearly you can see I multiplied here by q because I wanted to make it 3q squared. One of the q was missing here, so you multiplied it by q. And here q squared was already there, only 3 was missing, so I multiplied both numerator and the denominator by 3. The rest of the steps are exactly the same. And here why we cannot simplify it? Because they are unlike terms, we will leave them like this. Let's find the LCM here in question number 33. So the LCM will be, if I see the numbers 2 and 2, their LCM is always 2. Whenever you have same numbers, the LCM is the same number, right? Okay, y and x, because the highest power of y is 1 and the highest power of x is 1, so it will be x and y. Now see what is missing here in this denominator, 2y. So 2 and y is there, x is missing. So you will multiply here by x in the denominator and also in the numerator by x. This one has the other denominator, it has 2x, so y is missing. So you will multiply the denominator by 2 and the numerator by 2. So let's see what will be in the numerator. 3 times x will be 3x squared, and in the denominator we will have 2xy, and here 3y times y will be 3y squared, and in the denominator we will have 2xy. And when we want to add them, we keep the same denominator and then we place the numerators here together, because they are unlike terms, so they cannot be added together. Let's solve one more question. Okay, let's see what will be the LCM, and then I want you to complete it on your own. Better pause the video here, find the LCM also on your own, okay, and then play the video to check your answer. So here is the answer. The LCM was 15pq, because 5 and 15, their greatest common multiple is 15, and p and q, the greatest common multiple will be p and q, right? And the rest of the steps are exactly the same, and here is the answer, right? Okay, here we have some challenge. I have written some challenge questions for you. Better pause the video here, solve both of them on your own, and then play the video to check your answers. So here are the answers for both the questions. You can pause the video here and compare your work with this working. That's all for this video. Hope you understand it.